Artificial intelligence is at the forefront of technology, and as a professor working in AI, I have the privilege to collaborate with industry professionals. Joining me today is Adam Kalai. Adam gave a wonderful talk at TILO's HDSI colloquium. He is a researcher at OpenAI, which is one of the leaders in artificial intelligence. He has done a lot of work on various aspects of theory of artificial intelligence and applications. After earning his PhD from the Carnegie Mellon University, he held academic positions at TTIC and Georgia Tech before moving into industry roles at Microsoft and OpenAI. Recently, he has been working on key problems in deploying AI LLM systems, such as hallucinations and fairness. With his deep expertise across both research and practice, and industry and academia, he is uniquely positioned to discuss his career path and the current landscape of AI. I am excited to have Adam share his perspective and experience, and thank you for joining me.
Thank you so much, Misha. It's a delight to be here.
So let's start with some questions about your personal trajectory. What shaped your outlook early on, and how did you end up focusing on machine learning and machine learning theory in particular?
Right. So I started when I was in high school and college. I was interested in math. And then I realized that I was mostly doing that out of competition. I like to compete and I like to do well. And then when I started taking more serious classes, I didn't find it that interesting. And then I decided to try out the computer science classes, and those really grabbed me. And I was most interested in artificial intelligence. But at the time, it was very limited what you could do with artificial intelligence. It was still super intriguing, but progress was very slow, and the capabilities of an AI system were very limited. A computer couldn't distinguish a cat from a dog, and there were just so many things that it could do and couldn't do. It couldn't understand language, but nonetheless, it was still fascinating to me, so I decided to study what we could study about it at the time.
And were there any sort of specific formative books, mentors, or experiences that sort of moved you in that direction?
Yeah, Les Valiant taught a class on learning theory at Harvard, and I took a class as well from Stuart Schieber, and he took classes on natural language processing. So they were giving all these examples of how language works and how computers try to understand language but fail. And so I remember in this class, we would give an example of a sentence like, finally, a computer understands you like your mother. And then you would take that sentence, finally, a computer understands you like your mother, and they would show you all the ways that you could misunderstand that sentence, like the computer understands that you like your mother, or all the different options, and it fascinated me. So I just studied it out of interest, even though kind of the mistakes of the computer were more interesting than the ways it was succeeding.
It's kind of interesting. Right now we have computers which actually understand this, right?
Exactly.
This kind of sentence.
Exactly. And I was interested in science fiction like everyone else and all these things. But it's great now that the computers actually do understand language, because now they really understand what we mean. And so if you look at some of the fears that computers won't understand what we mean and they'll be misguided, those are fears, but if they understand language, then hopefully they understand our intentions, and or at least we can have a dialogue with them.
And sort of to come back to your research trajectory, you worked on a wide range of topics, from algorithmic theory, online learning, and some more applied projects as well. What is a sort of was there some sort of overarching theme that sort of guided your sort of your arc of research?
Yeah, I'm interested in thinking about different ways, new opportunities to model things. So usually I'm looking at something, and when I look at it, I try to take a different perspective than the way most people do, and a simple perspective. And so often I notice things that other people didn't notice, even though maybe they've been studying the problem for a very long time. So that's given me some opportunities to make contributions.
So that's interesting. You say that you look for things that other people don't necessarily notice. Any sort of any hints on how do you like other people, there are
Right.
very smart people who notice a lot of stuff. How do you sort of look for things which maybe are important but have gone unnoticed?
Yeah, that's a good question. I don't think I'm intentionally doing it. I think I might just think a little bit differently, which is an advantage in some cases and a disadvantage in a lot of cases. But when it comes to research, looking at things differently is an advantage. When it comes to maybe dressing or things like that, it's not always an advantage. But when you want to attack a problem, so I think it's just more that the natural way I look at things is a little bit different.
Any, to maybe graduates, to undergraduate students who watch this, any sort of?
Well, the advice, I guess, is when this happens, we all look at things differently, but when you look at something differently, go with that. Don't just say, oh, I must be wrong. You should maybe, follow that direction. So as an example, people for several years were looking at computers doing analogies in language. They were asking, oh, look, Paris is to France as London is to England, and things like that. And so I just asked a very simple question, well, what happens if we ask the computer, man is to doctor as woman is to, and see what it came out with, and sure enough, it came out with nurse. But it's such a simple question. I think it might have occurred to other people, but nobody actually did it and then followed through and pursued that direction and thought of the consequences of that kind of thing.
So maybe it's not just looking for things other people haven't noticed, but maybe people don't appreciate that some of the things have consequences.
Yes, right, exactly. Understanding what the importance of different directions is.
Mm-hmm. And I have to ask you this. Much of your research has been in theory, and we sort of now have this fairly difficult. Well, I myself, as being a somewhat theoretical researcher, theory and practice always had a little bit of a tense relationship,
right.
And particularly tense now, because there is a sort of, I guess, reasonable argument that, okay, the practitioners do whatever they do and they don't take advice from theory, and theorists are kind of far behind.
Right.
What does theory mean for you, and what do you think is its role in this brave new world that we have now?
I think it's a really exciting time for theory. Usually you think of theory as this abstract thing that may or may not be relevant, but I think for AI right now, at this moment, it's more relevant than ever, because we don't yet have AGI. We don't really have these super intelligent or generally intelligent computers. They're very smart, but we need to think about how to plan ahead. And theory is very good for formulating models and planning ahead. And one of the areas where theory has been most successful is cryptography. Because in cryptography, you want to design systems that are safe against an adversary that is more intelligent than you and has more computational power than you. And AI, previously the theory of AI was, about learning the percentage, it was very much like statistics with confidence intervals, and that's a very important and interesting part of statistics. But now we're moving to a point where we have AI systems and we need to make them very robust. And the way in cryptography you make things robust is you think about even an adversary attacking you. And I think we need to start doing the same thing in AI. So, for example, in cryptography, for years there were people just designing encryption systems, and then there would be somebody who would try to attack it, called red teaming. And then, decades ago, somebody came up with the RSA crypto system, and that encryption system, and that system has lasted for decades, despite the computers increasing in power millions of times. So, the reason it worked is because they came up with a principle based on theory, and they said under this assumption, this system is secure. And I hope that AI will move more in that direction of, getting guaranteed reliability, and that kind of forward thinking, designing something that will work robustly for decades. That kind of thinking usually comes from theory.
So you are pretty optimistic. I mean, I'm very happy to hear this. That
I don't know. I don't know whether to be optimistic or pessimistic, but I do think that there's a lot of room for theory to contribute, definitely, to helping us with safety.
So maybe switching gears a little bit, if I can ask you about your current position at OpenAI. And one question is, what attracted you to OpenAI, and how does OpenAI compare to, you had a lot of experience with academic and industry over the years, so how does OpenAI compare to them?
Well, it's a very different environment. In academia, you can think about a project for years and plan ahead. And now in the pace of industry, things are moving very quickly. So it's more about, working on what's going to be relevant in the next few months or maybe years, but it's very, more short term. But then at the same time, the tools we have are much more advanced, and things are advancing very quickly. It's exciting just to see the ability of the AI as it advances very quickly.
And what specifically attracted you to OpenAI?
OpenAI has some of the best language models in the world. So I was excited to go there to see if I could help them be more safe, more aligned, more fair in all the different ways. So I feel like as an AI researcher, that's one of the ways we can contribute is by trying to make the AI systems more aligned with what people want from them. It's a little different. I mean, in academia, you also feel like you're contributing, you're teaching students, you're coming up with ideas which could be helpful, which are helpful in the long term. At OpenAI, I'm working on systems that are deployed today with hundreds of millions of users, or maybe even billions of indirect users, And so it's a more immediate impact. It's a different type of satisfaction and a very different type of work. I'm doing a lot more programming myself than I did in academia.
Do you still work a lot with academic colleagues, or you mostly now kind of shifted to OpenAI?
I'm working more with people in OpenAI. Yeah, it's a big shift. As an academic, the lifestyle was very different. I would go to conferences. I would spend a week at a conference, sitting with friends, thinking of brainstorming, thinking big picture thoughts. And now, it feels almost like a career change, which, to be honest, at my age, I'm a little bit older, I'm one of the oldest people at OpenAI. Not at the whole company, but in my team. It's a change, but it's been fun because I've learned a ton. I didn't realize, how much I would learn from this switch. But the lifestyle has changed, my day-to-day has changed, everything has changed. And it's been fun and interesting, but also stressful. There's a lot of pressure. We know our models are not perfect, and we're really trying to make them as helpful as we can. And there's a lot of people who are passionate about that. But every day that goes by where they're not at the peak performance, is another day where we have the opportunity to make them better.
Maybe to talk a little bit about some of your research or some of your thoughts about topics related to your research. And one thing you've been working in is hallucinations. And I would like to ask you, first, what is so hallucinations is something that these models come up with when basically when you ask them a question, they come up with something which seems to be either completely wrong or invented or doesn't correspond to anything real. So maybe you can tell me a little bit your intuition. What's the relationship between hallucinations and creativity, which also has some of similar kind of properties?
Right. Some people are afraid that if you try to get a language model not to hallucinate, so the hallucinations are a big problem, and we're aware of that and working on that. Some people are afraid that if the language model stops hallucinating, it'll also not be creative. I think that that's not necessarily a problem. I mean, as humans, human is actually a language model as well. A human responds just like a chatbot. Here we are chatting. And humans know the difference between creativity and hallucination. If you were to ask me, what your birthday is, I know that I don't know your birthday. It wouldn't be particularly creative of me to guess it out of thin air, to make it up and confidently say something. But if you ask me for a story, I can be creative. We understand the difference, and I'm hoping that AI systems in the future will also understand the difference. So if you ask them to be creative, then they will be creative. But if you ask them a normal question, a factual question, then that would not be the time for them to be creative and make something up.
So do you think it's a question of context? Like inventing a birthday is kind of ridiculous, right? But inventing a story is perfectly reasonable.
Exactly. I think it's context. In the context of writing a story, you can make somebody's birthday up, no problem. But in the context of answering questions, giving factual information, you don't want to be creative. So I think these language models can play multiple roles. They in different contexts, they can respond very differently. Obviously, they can speak different languages. And so I think they have the potential, they already are to some degree creative, but I think that's something that we can see more of. And they are unfortunately too creative, as you say, when it comes to, sometimes when it comes to hallucinations and facts, and so that's something we're working on. But I'm optimistic that hallucinations will go down, and you already do see that over time, the rate of hallucinations is decreasing.
And do you think that there is a fundamental difference between sort of how humans hallucinate or create and how machines do it?
I do. So I've been working on hallucinations even before I joined OpenAI. And one of the ways to think about it is the way a language model is first trained, it's trained to predict what's coming next, what somebody's going to say. When you type on your phone and it sometimes offers you which word is going to come next, which word it thinks you're going to type next to save you some typing. So that's a prediction game. That's, it's trying to guess what you're going to say. And humans actually have a kind of language model. It's a simplification, but in the brain, there's a part of the brain called Wernicke's area, which is a language model that's designed for listening. And that part is designed to predict what somebody's going to say next so that you can understand what somebody's saying, especially in a noisy room or if you're trying to fill in the gaps. And then there's a separate language model for producing, for speaking. And they're two different models, because when you say something, you don't expect to say something that you don't know. But when you listen, you do expect to hear a lot of facts that you're unfamiliar with. And what happened is the way the language models were developed originally is they took a prediction model, which was just predicting what it's expecting to hear, what somebody's going to say next. And they repurposed that as a chatbot. So it was mostly predicting what you're going to say next. So if somebody says, Professor Mikhail Belkin's birthday is, the next thing that's going to come for sure is some date. A predictive model thinks, well, it could be January, February, March, who knows, but they'll just pick one. You would not hear somebody say, actually, I don't know. That's very rare. In stuff that you read on the web, you're not going to see so much, I don't know this, I don't know that. Whereas in a chat conversation, you do want more of that. So the prediction model works possibly similar to how the human brain's prediction model works. And what's challenging is getting something more like the speaking model, where you speak based on the knowledge you have rather than prediction.
So that actually nicely brings me to the next question. Do you think these models, so when the model says something like it hallucinates a birthday or something like that, we don't really know what's inside this model. Do you think the model may know that it's hallucinating? Or is it like, people sometimes do, right?
Right, that's a great question. There are a lot of papers that show that models actually do know to a large extent what is true and what isn't true. So for example, if you ask the model, when is Misha's birthday, and then it gives you one date, and then you ask it again, and it gives it another date, and you ask it again, and it gives you a different date, that's some evidence that the model probably ought to know that it doesn't know. And there's been a bunch of research showing that if you even ask the model after the fact, are you sure about that? It'll say, actually, I'm not so sure. So that's the challenge is the model might even know what it's more sure about and what it's not, but it's one thing to be able to correct yourself after the fact, and it's another thing to make the right statements on the first try.
So that's actually somewhat human behavior, right? We have, when students, for example, take a test, sometimes they would write something, right? And they sort of know it's probably wrong, but...
Right, yeah, a little bit. But I think that hallucination phenomenon, the reason we call it hallucination is it's very unfamiliar to humans. It's not something that we do that often. So maybe there's a stage of childhood. There is a disease called Wernicke's aphasia, but it's very rare, where people do produce actually from the listening part of their brain. They start speaking there. But I think people have the idea that they are speaking from their knowledge, whereas generally, or from their thoughts at least, whereas language models initially are trained as predictors. So they're trying to predict what the other person's going to say. Whereas if you were to ask me to predict what you're about to say, I would not be great at that. The language model can give a million predictions, and that's its strength, but that's also related to its weakness.
So that maybe is a little bit like the test situation, right? Because the student is trying to predict what plausibly the teacher is going to like, right?
There's
something which will get accepted.
Taking
by
a
the
test, I
teacher,
see what you're saying. Taking a test, you're trying to sometimes fake out the teacher or the grader.
You may know something, right? It's not necessarily you don't know anything, but you're not sure, and you somehow provide something plausible.
Yes. Mm-hmm. Yeah.
Right? No, not you personally.
Yeah. I've definitely taught classes and seen some students who, you're right, in the context of taking a test, it sometimes you might see a little bit more hallucination on the students' submissions, definitely.
You have done a lot of work on fairness and bias in algorithms and related topics. And so what attracted you to the circle of ideas?
As I said, I was mostly a mathematician originally by training. And actually, when I was at Microsoft Research, the managers there, Jennifer Chase and Christian Borgs, they arranged an interdisciplinary environment where they hired a number of social scientists. My office, my neighbor was Nancy Baim, who's a famous social scientist. And we had a number of people who were thinking about communication, discrimination. And they were telling us that you have to really watch out. These algorithms you're designing have a lot of influence and effect on the world. And I thought they were crazy initially, I have to admit. I was thinking, what does my matrix completion algorithm have to do with bias in the world? I'm just trying to design a faster algorithm. But some of the thinking of the people that I was surrounded by seeped in to my head, and then that's when I started to spot things. Maybe that was a great opportunity to spot things that machine learning researchers were missing, because I had this benefit of the interdisciplinary colleagues around me to give a different perspective.
And do you have any thoughts on what the right? Because you write paper. Well, I mean, now you're doing other things as well. But before you primarily wrote papers about the things.
Right.
And what is a sort of balance between some sort of technical or theoretical insight and how the things are implemented in the, I presume that's what you want to some degree, right? You want people to take this into account when they're actually developing rules.
Right. Now that I'm at OpenAI, there's very little gap between having an idea and having the potential to, affect a large number of users. If you make a change in the system, then it is used, widely. So at OpenAI, one of the things I've been worried about with fairness is what's called, we call it first-person fairness. So most of the discussion about fairness for a while in AI has been centered around decision-making systems. So some company, some institution wants to hire people or give loans. And so they're trying to decide, who should we give the loan to or who should we hire? And that's very important. And we want to make sure our AI systems are as fair as possible on the decision-making problems. But another new thing that's arriving with the generative AI is that an individual is going to ChatGPT or whatever system they're using, and they're asking for help. Help me get a job, and help me get a loan. And so instead of an institution making a decision, you have hundreds of millions or more people just getting assistance for themselves using the AI. And so I, just asked the question, which has not really been addressed well, is what does it mean even to be fair when a person is trying to use one of these things? And then we, try to evaluate the language models and see if they are being fair, and if not, we would need to fix it.
I see. That's a really interesting point. I haven't thought about how the systems have actually power over individual decisions, potentially. That's In what this, so you mentioned that the gap between somehow theory and practice shrinks a lot at OpenAI. Was it something that attracted you to go there?
No, another part of my decision to go there, honestly, was a little bit just to change of pace. I'd been working in the same wonderful place at Microsoft for 15 years, but sometimes it's good to change things up. And it's, as I said, a big career change. I also considered tenured jobs. In academia, you have tenure, and you're set for life. I chose not to go that route, which is a very risky move because, in industry, nothing is guaranteed for the rest of your career. But at the same time, it's very exciting and impactful in a different way. And, you never know how things will develop, but things are definitely moving very fast in industry. But I also think there's a lot of exciting work that can be done in academia as well. If I was a young person, I would be torn between the two of them. Since I had the academic experience and the freedom in the ivory tower for so long, for me it was exciting to move to industry. But I think there's great things that can be done also at the forefront of AI, like you work on, in academia.
Yeah, we'll get back to some advice you might give to young researchers in a little bit. So another question about sort of societal implications of this. From your perspective, how serious are concerns about aligning AI systems and human values?
As an AI researcher, I feel like it's all the responsibilities of all the AI researchers to do our best to make these as aligned as possible with human values. It's a complicated, complex question because you have to decide who to align with, but I think it's very important.
But do you share some of the sort of more severe concerns about existential risks and things of that nature? That maybe AI presents a risk to existence of humankind or human society?
I think it's our responsibility to think about all the possible risks, definitely, ranging from near-term to long-term, from simple, or not just simple, but concerns of today and concerns about fairness and bias, all the way to existential risk. I think they're all important and worth considering.
So now let's go to the question of education and how should the educational system adapt to this rapid advent of machine learning and AI tools and things like ChatGPT?
It's very difficult to integrate these AI systems, and I know there are challenges because the systems can be used to, in ways that make traditional education sometimes harder. But at the same time, they have a lot of opportunities for people who are creative, can think of new ways to use them to create new types of ways to learn and new kinds of assignments. And so I'm excited. I'm sympathetic to the teachers who have problems, but I also feel like there's great opportunities. I personally learned so much from these language models, even about things that I thought I knew a lot about, like programming. And I know that there are great opportunities for the students to learn from them. But it's a constantly moving target. These systems are getting smarter. So I think the challenge is to design new classes and new ways of learning, new exercises, let's say, that make the most of these language models without fighting against them and viewing them as sort of an enemy.
And I guess the sort of fundamental tension here is that, in universities, we're kind of a slow-moving, sort of conservative institution, as opposed to this incredible, almost instantaneous growth of the new technologies associated to AI. So it's kind of hard to battleship doesn't turn on a dime, right? It's like what should we? Any thoughts on how we should deal with this?
That's a big challenge. I know that's probably something you've thought about more than I have. What are your thoughts on that?
I think that we need to, I think we have no choice but to adapt rapidly. I think we have to essentially in some sense, we have to give up some of that conservative nature which we have as institutionally and just adapt, because if we do things the old way, it doesn't make sense, right? Like for one thing, when you give students homework, right, you know that they're going to use this model. This models are incredibly good at most problems. Like, they have to use this model, like as you said, right? Fighting against them is just not going to be productive.
Right.
But I don't have any sort of very good one. That's why I was.
Yeah. Well, and professors are very creative. I mean, in general. And another thing, obviously, is they can look around. So you can, if one professor in a small college in Iowa comes up with a great way to teach a class, maybe, and people are saying that it was very effective and they liked it, you can try the next semester to copy it. So, looking around and seeing what's working for other people so you can get the wisdom of the crowd in terms of, coming up with great new teaching strategies, I think would be wise.
And in some sense, these tools are incredible, right? You can just ask, like you can take one class and maybe just with that professor in Iowa, right? And you could just like, okay, like how would I model my class on that?
Exactly. Well, we both know, as I used to be a professor, when you design a class, you usually look around. Often you're looking for the most established classes, the best long-term ones, but now you have to keep an eye open for, a recent development, something that somebody might be saying, oh, that's really effective, a new idea.
And even at a very basic level, right? Like, before, like having handwritten notes, right? Like if you want to make them in LaTeX or some other format, it was this whole difficult process. Now you just take a photograph and it takes about 3 seconds to convert them to LaTeX.
Right.
Just incredible, right?
Yes.
Like, almost unthinkable.
Right.
So to go back to this question you mentioned before, some advice for young researchers. So let's go back to this. And for young researchers and for students and people who are maybe aspiring researchers, how should they navigate this? Like, because things change so rapidly, right? And but yet we cannot just say, oh, you have to know how to use like whatever the latest system is. What are the foundational skills? Are there foundational skills? Like, what should we tell our undergraduate students?
That's a great
You've
question.
seen both sides of
yes.
it, right? Academia and now.
Similarly, I think it's very important for the young students. They want to learn the fundamentals and learn, everything as before, but they also need to stay up to date with the latest technology and how to use it to their advantage. Because that's an important skill that they'll need, and how to adapt to an ever-changing landscape is something that will continue to be important in the upcoming future. So that's kind of a new skill, is how to stay up to date with using the latest technology for their advantage, of course within the rules of the university.
But what do you think? Like, I teach machine learning class, and you used to teach the same classes. I teach students linear regression, let's say, which is a basic statistical technique, or now we call it AI. From my point of view, this is very useful, because when you learn linear regression, you actually understand a lot about more complicated things. On the other hand, it's not unreasonable for students to say, oh, well, why do we need to learn all of this? This is all irrelevant. We just use these tools to tell us, if I want to do linear regression, I ask ChatGPT. And what should I tell them? I mean, what's your opinion?
Well, there's a lot of, technology is advanced always, and there's some skills do become obsolete. Nobody learns the square root algorithm anymore, but we do learn the addition algorithm and the multiplication algorithm, and there's still reasons why you want to learn the basics. And I use the principles of linear regression all the time in my work, even though obviously we have access to great language models that could do that for me. But when you want to use those things and you want to use them in a context of a bigger system, you have to understand the basic principles. So it's not enough to do something. Sometimes you need to understand when the right time is to use a tool, and you have to understand how it works and what the consequences are. So you really need to understand the fundamentals to understand which tool to use and what the consequences of using those tools are. So it's not enough to just ask a system to do something. Do you see what I mean? You're not always just executing linear regression. Maybe you're deciding whether to use that in some bigger system, and will there be a feedback loop or whatever, and you have to understand how those things interact. So it is important, in my opinion, to still learn the fundamentals of these things. So there are some, certain algorithms, like I say, or certain things that probably people don't need to learn anymore, but the vast majority, the fundamental ideas, I think we still want people to understand.
I think that's very valuable coming from someone at the sort of cutting edge of technology, that we still need basic things, the fundamentals like linear regression and things like that. Okay, so maybe to sort of, before we conclude, a final question. It's like, if you look back at your career so far, is there some sort of advice you would give to yourself as a young researcher?
It took me a long time to find the type of research that I like. I was kind of wandering for many years, and I tried many different things. I don't regret it. But I didn't spend much time thinking about what I enjoy. I spent a lot of time thinking about what would be impactful or what I could publish. And it's obviously very important to find what you like working on. That's a tough piece of advice because I don't know how one does that other than trying out things. But I probably wasn't tuning in enough to think about what I enjoy and more trying to be successful.
I think this is great advice. I could have taken it myself when I was a graduate student.
It's easy to give yourself advice in hindsight. The hard part is to think of what advice you need at the moment.
Well, thank you, Adam. This was really great.
Thank you so much.